there. Today we're going to look at geometric probability. And this is something that's used a lot, like if you think of in games, if you were playing darts or archery or something, you're looking at the probability that you hit a shaded region or a certain part of a shape. And as the area of that shape gets smaller, then the likelihood that you hit it is less, and thus it's worth more points. So this whole idea of geometric probability is what we're looking at today. To find the geometric probability of something occurring, you're always going to take the area of a success. So if you were looking for the bullseye or something, what's the area of that circle over the total area possible that you might have thrown that dart or something. All right, so area of a success over total area. That's our geometric probability. All right, so let's look at this one. Now, a circle is inscribed in a square. Point Q in the square is chosen at random. What's the probability that Q would lie in the shaded region? Okay, so a success is the area of the shaded region, and the total possible would be the area of the square. So I'm going to find the area of the shaded region. This is kind of a nice lesson here to wrap up this chapter because it does a nice review of all the different areas that we've come across in this chapter. So the area of the shaded region is simply going to be the area of the square minus the area of the circle. Because if I find the area of the square, that'd be the whole thing, but you can see that the circle is not shaded. So the area of a square is going to be, so I'll write square area equals, it's just base times height. Okay, so the area of that, it's a square, so 6 times 6. So the square area is 6 times 6, which is 36. Okay, so that's part of what I want. Now I want the circle area. That's circle area, and that would be pi r squared. So the circle area would equal pi. What do you suppose the radius of your circle is? Okay. The diameter of it would be 6, and so the radius is 3. So times 3 squared. So my circle area, I guess I'm just going to go decimal in this. Be sure to pay attention to your directions on how you should round. So that's really just 9 pi. I guess I'm going to write 9 pi for right now. And then this, I have to subtract 36 minus 9 pi. And I'm going to do that in my calculator. 36 minus 9 times pi. And I get 7.73, let's say. Okay, that's the area of the shaded region. Got it. Now I'm going to do the area of the square. Well, that's not too tricky. I'm not going to spend a lot of time showing a lot of work on that. So what I'm going to do now is the area of the shaded region is 7.73. Did all my work to find that. Over the area of the square, which is the total possible area, that's just 36. All right, and in my calculator, I divide those out, and I get 0.214. So it's like about a 21% chance is what that would mean, that I would actually pick a spot that would lie in that shaded region. All right, let's keep moving. Same idea. A triangle is inscribed in a square. Point T is in the square. It's selected at random. What's the probability that it happens to lie in the shaded area? Okay, so the shaded area are these two triangles. So let's work on the shaded area. I'm going to assume that these two triangles are the same. They're congruent to one another. So I'm going to do 2 times whatever the area of the triangle is. So I'm going to work on this triangle right here. It's kind of an upside down one, but here is our base and here is our height for that because that's a right angle. So the area, or the triangle area, would equal 1/2 the base, which is halfway across there, so that'd be 2.5, times the height, which is 5. Okay, That triangle area then is let's see, actually as a decimal, let me scribble that out, it's going to be 6.25. Now that's your shaded area. Oh, wait, no it's not. No, it's not. That's the area of my triangle. Now I have to double that. 2 times that triangle area would be 12.5. Okay, got it. Now, remember that it's shaded area over total area. So I got 12.5 over total area for the square, base times height, just 5 times 5. That's going to be a 25. And that would actually reduce, if you type it in your calculator, or maybe you can just look at it and tell me, it's a 1/2. So I'm going to say that the probability that it hits the shaded area is 1/2. Which really means, I don't know if you would have noticed this or not, but this right here, these 2 yellow pieces are actually the same size as this white triangle here, which should kind of make sense, because if I just draw in, let's say, just draw a line right down the middle, this triangle and this triangle are identical. This triangle and this triangle are identical. All right, this one's going to be a little bit trickier for us. On this one, we're picking our point K, but notice that it says, what's the probability that K lies in the area that's not shaded? Okay, so now I'm looking at these white pieces, whatever that would be, over the total area. Okay, so the white pieces that I'm looking for, that I'm considering a success, is the not shaded part. I would have to do the hexagon area and subtract the circle area. Okay, so that would be the not shaded part, and that would be my numerator. And then my total area over here would be the hexagon. That's a little bit harder for us. So we've got, ultimately I'm going to find the area of the hexagon, I'm going to find the area of the circle. Those are the things I need to find. All right, so let's look at the area of the hexagon, because that's going to be the trickiest part. So hexagon area is 1/2 the apothem times the perimeter. Okay, so 1/2. Now this really isn't as bad as I thought it might be. This is kind of like the diameter of your circle right here. That's 18. But remember that the apothem actually comes from the center perpendicular to the side. So ultimately, the apothem is the radius of your circle. Okay, that's not so bad. So the apothem is actually going to be 9 then. Now your perimeter, that's also not too bad, because they gave us this side right here. That's 10.4. I'm just going to take that times 6, and I get 62.4 for the perimeter. Let's multiply that stuff all together, and I have 280.8. That's the area of the hexagon, which is actually what I'm going to need over here also, right? Now I'm going to find the area of the circle. So this is the circle area. That's just pi r squared. And the radius is 9. We talked about that. And so then I'm going to subtract these two numbers. So 280.8 minus pi r squared, that's 81 pi. And I end up with a successful area, which is the not shaded part, as a 26.33. That's a success. Remember, now I'm going to put the success over the total. So 26.33 divided by 280.8. And I have a 0.094, let's say, probability that that's going to hit the non-shaded part. Okay, that's pretty small. That's like a 9%, and that makes sense for my picture because there's not really much that's not shaded there, so it'd be a pretty small probability. Okay, let's do some of those like archery problems or something that I referenced earlier. So it says, assuming you definitely are going to hit the square target. Okay, so you're not going to shank it off to the side. What is the probability that you hit the bullseye? Okay, so then if I'm doing geometric probability, a success is the area of the bullseye. That's going to be on top. On the bottom is my total possible area, which we decided we are going to hit at least the square target. So area of the bullseye over area of a square. Well, that's ultimately just, the bullseye is pi r squared. Pi times, and the radius is 1 squared, over the area of my square, which is 18 times 18. 3.14 over 18 times 18, I think that's like 386, 326, I don't know. 324. Okay, whatever. All right, and then go ahead and divide that out. So 3.14 divided by 324, and I have, ooh, very, very unlikely. I ended up with a 0.009. 7 if I had to do that. If you do that, that's less than 1% chance. If you look at moving your decimal, that's, well, your answer is the 0.0097. That's your answer. But that's less than 1% chance that you're going to hit that bullseye right there. All right, well, good luck. I hope you're good. Okay, so let's say we're not going to end up hitting the bullseye. What's the probability we get that yellow ring? Okay, this is a little bit trickier because the yellow ring is kind of like this donut shape. And to do the area of the donut shape, you have to do, like, we have, let me do this. Let me change colors. Here's the yellow part, and I'm going to have to subtract out the blue part here in the middle. I'm going to find the area of the yellow circle, subtract out the blue circle, and that's going to be my donut shape. That's going to be the area of a success here. All right, so area of the yellow circle, the outer yellow circle, so it's this circle right here, that has a radius of 2. So I'm going to go area equals, pi times 2 squared. But then I'm going to have to subtract the blue circle, which we know is pi times 1 squared. All right. So I can simplify this. This is just a 4 pi minus 1 pi. And you can actually subtract just like that, just like it was an x. 4 pi minus 1 pi, that's 3 pi. So the probability of hitting the yellow circle is 3 pi. I'm sorry, well, the area of the yellow circle. Or yellow ring is 3 pi. And now that's a success, so I'm going to put 3 pi over the total, which I learned last time was 324. Now let's try that. Hopefully our probability is a little bit better, but I bet it's not amazing still. All right, I have a 0.029, so almost a 3% chance of hitting that. So I'm guessing my square must be way too big. My target's too big, because my likelihood of doing well on this isn't very good. Okay, that's all I have for you today. Good luck.